Hello guys, so today we will be solving this problem, remove all occurrences of a substring. Okay, so the problem says given two strings s and part, perform the following operation on s until all occurrences of the substring part are removed. Find the leftmost occurrence of the substring part. Okay, so we have two substring, first one is s, another one is part. So what we need to do, we need to find the leftmost occurrence of the substring part and remove it from the s. Okay, suppose we have abc here, we will start from left and we see this is a occurrence of a part in string s. Okay, so we need to remove it. Return s after removing all the occurrences of the part. A substring is a continuous sequence of characters in a string. Okay, so let's see examples. So okay, so first string abc is this, we have removed this. Okay, so we have to remove, and after that we have to reiterate in the let's say the string which is a modified string, means after removing abc from this string we have this string left. Okay, now we need to find abc in it, so here is abc, and after removing this abc we are left with this string. Now in this string we will find abc. Okay, so what we are doing is we are modifying our s string, means we are starting from left. Whenever we found a occurrence of the part, we will remove this part, and we will after removal we will concatenate the remaining part, and we will repeat the process. Okay, so okay, so I think question is clear, but let's start with the brute force approach. So what we can do is we can do something like we can uh, means follow this approach only, means we can brute forcefully look for the part in the s string, and we can remove its occurrence, and then we can form a new string, and in that new string we can check for this occurrence of this part, and until we let's say don't find any occurrence of part in the string s. Okay, until we don't find the string s. Okay, the string part in s. Okay, suppose we start, let's say we have n as the length of s dot length. Okay, and m as the length of part dot length. Okay, so what we need to do is we need to iterate till n minus m. Okay, means we are starting from 0th index, and where we are stopping at this index, because after that we will be not having the sufficient length as of part. So what we are doing, we are from this n we are subtracting this length, so we will our I will at most reach this position by doing this check. Okay, so what we can do, we can compare if s dot substring starting from I in s and ending at I plus the length of this particular uh, part substring. If this particular substring becomes equals to the part, then we need to remove this substring. Okay, then our new s will be s dot substring starting from 0 and ending at I. Okay, plus s dot substring starting from I plus m minus 1 and ending at the length, so we don't need to put the second, let's say second parameter, means the ending parameter. So if we don't pass any ending parameter, it will consider the whole string after this particular index. Okay, and after that, suppose we print our string. Okay, so we will print our string after this. Okay, system dot out dot print ln s. Okay, suppose at the end we return this. Okay, so let's see what we are getting. Okay, we are getting out of bound equals part I plus m. Okay, okay. Wait a second. This range 6 and 9 going out of bound means suppose we are at 6. Okay, then 6 plus, where is the 6 index? 0, 1, 2, 3, 4, 5, 6. And what we are doing? We are okay, so we have modified our string, so that's why. Okay, suppose we find the first occurrence and we break. We need to put equal. So wait a second. So what we are doing, we are breaking whenever we find the first matching occurrence. Okay, so what we are printing after removing the first occurrence. So we have removed this occurrence ABC, and after removing this occurrence, we are getting this string. Okay, so we need to, so we are taking string from 0 to I. Okay, okay, we are having this here. Okay, 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 so this is the string after removal of this ABC, DABBAC. Okay, so let me just copy this. So this is this our code is removing the first occurrence. Okay, but what the question is asking, we need to remove all the occurrences. So to find all the occurrences, what we can do, we can run over this while loop, while is true, and we will run this code as many as time until we don't find a occurrence of part. Until we don't find a occurrence, we will means run this loop. Let's say we initialize a boolean uh, part found, and initially part, we haven't found the part, and when we reach this condition, we can say that we have found the part. Okay, so we can break over this while loop, which is running infinitely now, when we say that we haven't found the part in our string s. So we can say now no occurrence is present, we have removed all the occurrences, so we can break, and after at the end we can return the s, that we have removed all the occurrences of the s. So this is the brute force way. Okay, So we need to as we are modifying our s string, so we are also basically uh, uh, we need to means initialize this n locally, means we are taking the original length of the string. So what we can do, uh, we can initialize our n here, means we can say that current length of the s is this. Okay, so this code is working. So this is the brute force part, means we can do it using brute force. So this is a brute force solution. Okay, so let's think, can we do better? Means we are reiterating our string. So how we can calculate its time complexity in worst case? Let's say we have a string n, sorry, we have string s containing all a's. Let's say 100 a's, means our n is 100, means length of s is 100, and our part string is a single a. Okay, so what we are doing here is in worst case we are running our this code 100 times. Okay, here we will be running this code 100 times. Okay, this is not the worst case, because this is in big of n time. Suppose we have a string something like this, means 50 a's 50 b's, and we have a part string like this. Okay, so every time what we are doing, we are starting from this position. Whenever we found this, we break this loop. Oh, okay, so means we are iterating n times. Okay, then we again start from start, then again n times, then okay. So basically this is a n square, roughly we can say this is a n square solution. Means we are running, means 50 let's say n by 2 into n by 2 plus 1 by 2. So typically this is a n square solution. Okay, so these are the conditions. So I think according to these conditions this can get submitted. Let's see if this gets submitted. Okay, but I think this is a brute force solution, we need to think something better. Suppose we have this case which we were considering for analyzing time complexity. On this is our s string, and our part string is ab. Let's say we start from here. Okay, we see a. So the first match will be here when we reach this position. Okay, so we need to remove this position, and now we need to consider this string. Okay, So let's so like if we use a stack, so what we can do, suppose we have a stack and we are putting a, then we are putting a, so let me shorten this example, let it be like this, then we again put a, then we put a b in a stack, so we see b is the last in our part string. Okay, then we pop out b, then we see a is the last string. Okay, so we have found the part string, so we don't need to put back it into the stack. Okay, but let's say we have a c here, then in that case this particular peak of the stack matched, then we have removed this part, then our this c doesn't match with this part, so we need to put it here again. Okay. And if this part is not matching, then for future we can say we were never going to pop these elements in from our stack. In worst case what can happen is, let's say we have c, a, b, d, f in our string, in our stack, and as of part we need to find, let's say a b, d, f. We have found a f, we have found a d, we have found a b, we have found a. Now we need to match this a, so we haven't found any a, so in that case we need to pop out this. Okay, means we have popped out these elements, we need to put these elements back to the stack. Okay, or we can, means putting back the elements into the another stack is seeming me costly, so can we do something else, like, means we can have a condition like we don't have to put back this particular part in the stack. Okay. I think the part which is not matched now will not match in the future. Why it will not match in future? We are having this 3 and 4. Okay, four elements, and this is the element which is not matching. But let's say we have something a a b b c c, and in stack we have a, and then let's say we have c, a b and a. Okay, so we will match elements till this position. Okay, so now we have this b. Okay, so this b is not matched, but these two elements can be used in future. Okay, can we use some? Okay, means element which will be reused will be ultimately less than the original length. uh, if we have two a's and a b and a c, let's I'm not able to figure out that how this tech will gonna help us. Means it is for sure that we don't need to reiterate our whole string. Means it will be optimized than our previous approach, but I am thinking that how we can calculate exact time complexity for the stack part. What I'm trying to say is, let's say we use a stack okay, and we start from our string s. Okay, and what we do, we put the so we need a stack of let's say character, so we can put into our stack the current character. So this is the current character we have added to stack. So now what we can do, we start from last character of this part. Okay, and while this means the character at jth position in this part matches my character at peak of the stack. So what I can do is I can simply uh, pop out from my stack, and I will decrement my j. Okay, and at the end what I can do, I can, okay, and also j needs to be greater than equal to 0, and my stack also not needs to be empty. Okay, what I can say is I have found the part. If my j becomes -1, means it fails this condition. We have decremented it this much that we have found all its character. So we have found the part. But what if this doesn't reaches -1? So we need to put back the elements which we have popped out from the stack. Means in this case we need to put back the put back characters in stack. So what we need another stack, stack, another stack of character. Let's call this temporary stack. So we need to add the characters which we are putting into this stack. And we need to re-put in the case where j is -1. Into our this stack, means from which we have popped. And at the end we will be left with characters in our this stack. Can we do like this? Let's run this. Where's the run option? Okay, I think this will give the syntax error. Okay, so what we can do is, okay, mm, let's say we are here and we pop out this element. Okay, then we are here, then we should pop out this element. What we are doing, we are starting from this position I is equals to 0. We are adding the character a in the stack, then we are making a temporary stack, and while our original stack is not empty and the character at jth position is equals to the peak, we are popping out, and until j equals to -1. Okay, we are doing this. So let's print our original stack here, that what problem we are getting. So till this position we have this. Okay, now we reach this position. So we have added y to our stack. Okay, and we find our j, which is this. uh, j will be y. Okay, and j is greater than 0 and our stack is also not empty, and the this part dot character at j is also equals to the peak. Okay, so we have popped out the y. Okay, then we decremented j and we go to this position. Okay, then we see j is greater than equal to 0 and our stack is still not empty, and part dot character at j is equals to stack dot peak. Okay, so it should not be equal to -1. I think that's the mistake we are making. Means in the case of -1 we have found the character, we don't need to re-add it into the temporary stack. Okay, this is slow as compared to the solution which we have used. So what can be the more optimized solution for it? Note that the new occurrence of the pattern can occur if you remove an old one. Okay, this is we know. Okay, you can maintain a stack of character, and if the last character of the pattern size in the stack match the pattern, remove them. What it's saying, you can maintain a stack of characters, and if last character of the pattern size in the stack matches the pattern, you can maintain a stack of characters, and if the last character of the pattern size matches the stack, matches in the stack, match the pattern and remove them. So I think that's what we are doing. Okay, so this is without doing, without using this tag. Okay, we can also use this solution. So this is basically using the property of the string builder, that string builders are mutable. So we are checking that the length is greater and the last uh, part length characters matches the part, then we can delete that from the substring sb. Okay, it's same as the our previous solution. So can we see some more solutions? Okay, I think these are the only solution possible. Okay guys, thank you.